So here we're going to use the CAS calculator to find a sample size. We'll let x be a random variable that's binomially distributed with a probability of success p equals 1/6. So we don't know what the number of trials are or the sample size, and that's what we need to find. Here's a typical kind of question. What's the least number of trials required so that the probability of x occurring at least twice is 0.75. So how many trials do we need to get to a probability of 0.75 if we want the probability of x to be at least 2? That means x is greater than or equal to 2, and normally we would just use a binomial CDF. So let's have a go at doing that. We're going to add distribution, discrete, binomial CDF. Now the lower is going to be 2 because we want at least 2. The upper we don't know. Really the upper is going to be the number of trials. So in this case we'll put x. The number of trials we don't know is x, and the probability of success is 1/6. Now we get this wrong argument type message. We just ignore that. And up here on the top right, where it's got the graph, we go into our graph and table icon and just drag our binomial CDF statement into Y1. And what we're going to do is create a table. Now we don't know how many trials there are, so we're guessing maybe there's not going to be 5 trials, there might be more. I'm not sure how many trials there are going to be, so I'm going to just go till 50 just to check. We can change it later. And we tick Y1 and we want a table of values, so we go and click here, and you can see there that we've got a whole lot of trials, and we don't have a probability of 0.75 there at all. But if we scroll down, we can see that it's growing, and we can see that at 15 it's 0.74, 16 it's 0.77. So the time, the number of trials at which we get a probability of 0.75 is 16, so we need at least 16 trials to get 0.75. So that's the answer, 16.